All right, good afternoon, everyone. Yeah, I'm talking a little bit different from what the previous speakers talked about for reduced protein diet. So in here, our focus is on the insoluble fiber and also protease. So Nichelle is the person actually did hard work, and Sabas is involved in the project as well. So I acknowledge these two young people. So just a little bit of background about the insoluble fiber. So it has been shown that insoluble fiber can help on gut function and improve the feed efficiency and the nutrient digestibility. It can also help to the secretion of the pancreatic enzymes, in particular some proteases like pepsin, trypsin, etc. And actually, in our previous study, we found that the fiber, in particular sugarcane bugars, can improve the protein digestibility. So that's why we thought about to use it for the reduced protein diet. And also, intuitively, you can see that if you use lower protein diet, probably we need to explore more from the diet about protein or amino acids. So we thought about protease, exogenous protease. It has been also shown that the protease can increase the protein digestibility, of course, and improves the performance. But protease is not really very commonly used, I mean, still used, but not as intensively as other enzymes like exogenous and the phytase. Probably just because in the normal diet, you have sufficient protein or amino acids in there already. You don't need to use protease to, get more out. And also for the research as well, there are some outcomes, but it's not inconsistent when it's useful. And then we probably think about to combine protease with other additives, see whether, just in particular combinations maybe help. So the hypothesis based on background is that insoluble fiber may improve performance with low protein diet. And also the protease may do the same. So that's why we are looking into these two factors. And also there's a possibility we just combine them. That's the hypothesis we have. Maybe that can help in the low protein diet. So that's pretty much the design of our first experiment for the project. Basically, we have the 2x2x2 design. You can see from here, we have normal protein, reduced protein at the level in finisher and in the grower and finisher. You can see, and we added or actually formulated sugarcane bugars at 2% when we want to have the fiber. And we also put protease in to see whether they can help the birds to grow or improve the feed efficiency, or whether they have interaction. So that's a full factorial design. So we used Ross 3 or 8 prenatal male birds, and the treatments were during the grower and finisher stages. So we had 6 replicate pens and 14 birds per pen. So that's roughly the diets. I won't go into details, but that's basically, you can see the crude protein level, that's the calculated, but actually when we measure the protein level is slightly lower. So that's the data we can show today. I just show you some significant ones. For feed intake, as what you can expect that the low protein or reduced protein one after, well, they eat less. So it's pretty significant, but there's no interaction. And for body weight gain, there's interaction. It's really amazing that you can see the protease at normal protein level without the fiber actually increase the body weight. And when it's in the reduced protein, with fiber added, it increases the body weight gain as well. For fiber, for the sugarcane burgers, we cannot see really significance, but numerically, you can see this one and this one. When there's reduced protein, with the protease added, the fiber is doing a little bit, improvement. And here is the statistical analysis result. You can see the p-values here. Crude protein is always significant for the feed intake from grower until the end of the trial. The weight gain here, that's mainly during the actually 10 to 24 days, as what I show here. So for the FCR, we can see interactions, but not a three-way. So in here, you can see two-way interactions between crude protein and protease, or burgers with protease. So during day 24 to 35, they're significant. So in here, you can see in the normal protein diet, the burgers, when you add burgers in, so without protease, the FCR is improved from C to D here. So these two columns. And when in the reduced protein diet, with protease added, the FCR is reduced. So seems the fiber is doing something on the efficiency. Well, you are looking at the protease. It's also, so this pair is also doing something. It's improving the FCR when there's fiber added. So from this result, we can see that the protease and the fiber is doing something to improve the feed efficiency and weight gain in some way. And then we look at the relative gizzard weight, because it has been shown in the literature, the fiber is working on the gizzard especially. So we confirm the observation of previous studies. So the gizzard is increased when you have 2% burgers added in, both at day 24 and day 35 as well. And for reduced protein, we always think about fat pad, right? In here, we can see an interaction between protease and crude protein. So at normal protein level, protease can reduce the abdominal fat. In here, it's significant. But when the protein is reduced, it cannot do much. I guess that's because maybe the protein level is too low. And by the way, in here, in our study, we actually didn't add other amino acids apart from what you do for the normal formulation. So no glycine added or other non-essential ones added in. So and also when you are looking at the reduced protein diet, we think about feed intake, water intake as well, because, as what Peter has said, that when you reduce protein, you can improve the lead quality. So water intake is one probably factor, major factor to affect the lead quality. So in here, we measured water intake, and when we calculate the water intake to feed intake ratio, we can clearly see reduced protein significantly reduced the ratio between the water and the feed intake. So normal protein 1 has much higher, that's 2.1 something, and then reduced protein reduce the ratio to below 2. So that's very interesting. For water intake, it's really hard to measure, but we managed to use the facility, that's automated facility. We measured water intake here. And actually protease, you can see when you add protease in, it seems it increased the water intake. And we haven't thought through about the exact mechanisms, but we think if you add a protease, probably increase the metabolism, then need more water. So that's probably the natural thinking. Okay, so that's some message for you all. We think probably we can use protease in the reduced protein diet, but to what extent probably we need more research. And of course, insoluble fiber as well, that can probably improve the performance in the reduced protein diet. Maybe we need to look into amino acids as well in combination with these two factors, protease and fiber, probably can make the lower protein diet or reduced protein diet even lower. Okay, so just acknowledge our poultry group. Without bigger group, we cannot really do the trial. We have a lot of sampling during the trial and the animal house at University of New England as well. So Karen Gurney, we really acknowledge her contribution to the project, and of course, AgriFutures for the funding. So thank you, everyone.